Now let's start. Hello everyone, I'm Chen Yuan from Jingdong. I'm now working at the Jingdong Silicon Valley. I'm very glad to share the experience on the large-scale container platform for the Kubernetes optimization. In the morning session, I'm not sure if you have attended my session. I guess you must be familiar with our company. I just want to say our company is quite complicated and a large-scale platform, so the management and automation have some challenges. Well, as you can see that same with the large-scale internet companies with business growing dramatically over the past years. So the business complexity increased dramatically, so that we have many challenges when building some infrastructure, and our system have to be stable and flexible and efficient, and reduce the cost, which is quite important. Well, internal private cloud in Jingdong, responsible for Jingdong Suke, Jingdong Logistics, and other business. If some of you are familiar with Jingdong container development history, you must know that the container development started quite early in Jingdong. Actually, early in 2010, we adopted container mechanism, and in 2016 we have started the Kubernetes. And for now, most of the systems are containerization. And we have already done some Kubernetes experiments, and we want to have more reaction with the community and do more contribution to the community. Well, for our journey, I want to elaborate that specifically for you. If you want to start the Kubernetes or you want to use a container, we want to share some experience and lessons with you. Well, actually, in 2014, we start from 0 to 1 to start the containerization. And at that time, we use OpenStack to do the management. And then to 2015, and we want all things to run in the container, such as deployment and other works. And gradually later, in 2016, and we use open source Kubernetes from Google to migrate that into our system and to have a whole ecosystem. And later, we transfer that into the iPaaS platform to have the more automation. And actually, we are the early adopter of the container, and we have been a large-scale adopter. And the stability, elasticity is quite outstanding, and we have rich experience. For now, what we want to do is to improve the efficiency and reduce the cost to have the efficient management. And we want to optimize the management, and we want to magically resolve the problems that we encountered. While in our container management, we have a system we call the JDOS or JDOS, which is a short for the JD Data Center OS. Actually, it's a customized Kubernetes for Jingdong. Actually, in 2016, when we adopted the Kubernetes, many things were not mature, and we encountered many difficulties. And for that, we have optimized some shortcomings. And for now, at the very top level, we want to do the optimization. We want to measure a thing. Since if we want to optimize something, first we need to measure that. And for the regular the stapling system, we call it Archimedes. And JDOS is a core, and we have some open source document system, and we now call it Container FS, which is open source. And later I will just elaborate in another PPT and welcome you can use that. For the lowest layer is about the mixed resource pool. Well, for resource struggling, or for a broader sense, for the management in Kubernetes, we have many challenges for our Jingdong. First is about the accuracy, how to accurately predict the amount of the resource so that we can offer the precise or accurate prediction. If over, the resource will be wasted, and if the resource is less provided, the scenario will be worse. For example, for another part is a complexity. Since most of the work are actually packed into the container, for example, the readiness and the message system are actually all run in container. Besides, it's a multi-dimensional resource optimization with I/O bandwidth and disk. And besides, actually, we start some large-scale projects. For example, the IoT, AI, and the big data migration. We want to have a centralized management. Besides, we want to talk about the scalability. For the community, the largest Kubernetes community cluster, we can do the 6,000 to 8,000 nodes, and we want to deploy 2,000 to 3,000 nodes. Actually, we will encounter many problems. For the largest cluster, actually, for our Jingdong, it's over 10,000 nodes, which is not very common, but some business needs that. We also have some another solution, but it's not that critical for our Jingdong. For the large-scale business, we want to have a large-scale cluster to manage that. So for this, we want to have the scheduling optimization system, we call it Archimedes. We want to focus on the scalability for the large scale. How to ensure the stable performance, the Kubernetes performance. First, we do some customization, and second, we do some optimization. At the beginning, we have met many problems, but now we do some optimization for that. And besides, how can we improve the scheduling quality? So how can we lift the resource utilization to the maximum level? As I mentioned, based on the historical data analysis and the prediction, we can do the mixed struggling and with the mixed workload placement. I've introduced that in detail. I will first talk about the bottle it may encounter. I will just give a relatively large-scale application for that. For example, we have 1,000 nodes and 25,000 pods and 15,000 config maps. I would say this data may be some old-fashioned. I did not update it timely, but we can find some bottlenecks. First is about the etcd storage. Since in Kubernetes, all the resources are stored in etcd. So for etcd, we optimized that. We classify that into different classes and classify into different resource types. While for the data amount, we do the data compressing. Besides, we also have performed the Redis caching. And for the second part, we want to have the API server to do the regular reaction. For API servers, it usually becomes a bottleneck since the KPI cannot reach the requirement. After analyzing that, we found some config maps of the API servers of some certain nodes takes up a large amount of resources, which is usually unnecessary. So we want to change that. While during the scheduling, actually it consists of two steps. First, we want to identify which nodes can be the post-movers to scheduling these pods. According to your business amount or business size, not all of the nodes requirements must to be achieved, which is quite time-consuming. For example, we delete some node no disk scenario required nodes. But for the fourth part is about the image from the user point. The user wants so many containers. When these containers can run? Actually, some are the queen and some are scheduled. After that, some images need to configure. If we talk of the image, we found some library or some base. They may take maybe several seconds or minutes or even hours. For like the localization and P2P distribution and some advanced optimization techniques, I will just skip that since it's not the main part of my presentation. Well, back to the etcd and API server optimization. And here, this slide shows the results we achieved in the early period. For the schedule latency, we reduced by 90%, and etcd rate and read and write rate increased by 70%, especially for the etcd reducement. Actually, it's about the API servers. Most requests are constrained to the config map. And if not that overlaid, we will just delete this request. Well, in the latest version in Jingdong, we first run the Kubernetes 1.6 version, and for now we have the 1.2 version. Of course, we have done many optimization and customization of these versions. Of course, the API servers must be the main bottleneck. Well, for the stability and performance, when we're planning, sometimes we can achieve we will encounter the fact that the whole cluster is quite busy, so that we have implemented some control and preemption optimization to do the admission control. Of course, for the community version, if it is busy and the scheduling will fail, and we have to and the scenario will be worse. So we do not need to reschedule these resources into the single device, and we can optimize that when the jobs is in the queue, especially when the rack is quite busy, so that we can have a better control of that and better management of that. Well, for struggling, we really want to have appropriate control and drive out mechanism to ensure the system can have a good performance, will not be worse. Well, since I mentioned the problem about the customized Kubernetes, and we can optimize that to meet the system requirements. Besides that, we have another question that we newly found. We have two problems for the e-commerce or online services, and to the large scale stock enlargement and big data analysis and Spark batch job. It has a feature that at one time, an application requires a large amount of data or large amount of resources or containers, and it may run for 3 or 5 minutes. And for instance, suddenly it requires 100 additional containers. If you're familiar with the schedule for Kubernetes, it is pod by pod schedule. It needs to match the perfect match pods. If you want 500 containers, well, the whole process is quite time consuming. So you want to optimize the process. For example, we have a very simple strategy. If we want to struggling the same size container, we will select the first 100 container and distribute that. Well, if you are familiar with the straggler, and actually this is a research from the Cambridge University. They come up with a Potson and Fryman net. It is a workflow focus on nodes to nodes or nodes by node. And if you require a large amount of container with the same size, the efficiency will be 10 or 20 times of the current community version. So if you do not have the high quality, you do not have high requirements on the quality, but on the time, you want the large amount in a short time. You can use this. For now, the Kubernetes has been the standard data and OS and an OS platform. It requires a certain workload and database.
And this is what we are going to do just now. You may notice in different scenarios we have different needs, and at present Kubernetes can support different schedulers. So one to optimize is we can target it as our needs so that we can choose different scheduling strategies and different parameters. For example, if it is long-running business, for example in Jingdong, in JD, if it is a long-running service, then I think we can spend some time to use some complex algorithms to optimize it. However, for the batch one, we can use a rapid one, so at the sacrifice of some quality. So these are some parameters or different algorithms or parameters for different workloads and scenarios. For example, how many nodes that we need to find, maybe 50 or even 60. And this can be provisioned or this can be configured. So if it is a long-running service, for example, we can optimize it. Maybe if it is of low requirement, just 10 to 20, that's enough. So you can configure the parameters. So for different workloads and different scenarios, we should choose different scheduling optimization methods. So a brief summary is, in order to better the performance or the scale, we need to optimize the scheduling and different strategies. We should also take those into consideration. Also the access control, admission control, in order to ensure that when it is very busy, we can have still a stable scheduling system and it will not have the crash or some serious problems. And the second point to make is how to effectively realize scheduling, how to realize it efficiently, to improve its efficiency and effectiveness. And our mentality maybe about intelligent resource management, and we can, because we have a large number of IT data and the utilization, the resource utilization, so we can add some machine learning algorithms to help us to make decisions. And on the one hand, it is intelligent. On the other hand, it can save the cost and to improve its effectiveness. At present, our system, it is a closed-loop system for monitoring. For example, we have the second-level monitoring so that we can collect the statistics and to predict and then to some optimizing strategies and then to give the feedback. So this is just a general framework process. So let's come back to the decision making. So with this framework architecture, how to optimize the scheduling strategy? First, just as I've mentioned this morning, our database is doing the CPU and memory sizing. That is to give them an appropriate size of CPU and memory. For example, some overcommitting according to some data, the historic resource usage statistics, and future demand prediction. And second is to choose the appropriate server so that the whole total cluster can work more efficiently. And also we can have hybrid in different resources pools, how to schedule. And next I will introduce the details. So detailedly, this is the architecture of this closed-loop system. This is the container clusters, and you can see from the slide the pink part. And we emphasize a lot the real-time monitoring. It is of second level for a large number of data, and we now have a time series database. Also ClickHouse, it is another open source database. So after collecting the data, we can analyze the historic data, and also we can have demand prediction about its periodicity, stability, and correlation, and then we will forecast. and then have decision making. So I think these are 3 RQ for the resource management. That means the first is right size. The sizing of the container, you need to have appropriate size, not too large, not too small. And the second is right location, the pod placement, in which cluster, in which server, and in which rack, even in which database, data center. And last one is right time, when to schedule it. To schedule this one or another one. So the decision making mainly it is about these 3 R's. And for right sizing, our basic over-committing strategy, targeting at workloads, will according to its metadata to classify it. And then we have an initial setting configuration. So after running for some time, we will, according to our data analysis and prediction, we will have some adjustment. So more detailedly, this morning I also mentioned this, that we have a mode of the right sizing of CPU resources. For every container and every resources, we have requested and we have a limit. So we use requested resource. It should not be its maximum resource. Maybe just 90 percentile is enough. And the headroom, that means the rest of the room, the rest of the capacity, and the maximum should be 99% percentile. And that means all the containers on the server, we should give them a buffer to share, to realize common share. And I will take this as an example. Maybe too many numbers here. So let's just assume that every server has 9 containers, and we will classify all those containers if they are highly correlated with each other, and that means if they will reach peak at the same time, so that we will classify them within the same block, and we need to ensure them. Another of the green part is an additional resources. It may be the maximum, but we cannot guarantee. So altogether from C8 to C9, this is the requested resources for schedule, and this is the fundamental resources. So the green part, we do not need to add H1 to H9. If they are correlated, that means if they reach the peak at the same time, we can add them. But if they are not, we can just choose, select some of the numbers, for example, from H4 to H7. And that means on the one hand, we have requested resources, which is not the maximum capacity. So the sum, the maximum value, it is, and I will take this as an example. On the right side, this image, horizontally and vertically, it is 0 to 60, and this is the correlation. So if it is dark, then it means it has high correlation. And as you can see, the black line, that means they are highly correlated with itself. You can also identify some dark blue parts and some green parts. So that means if you just randomly distribute it, they will not reach the peak at the same time. And on the top of the slide, this is the maximum, according to its 90 percentile and 99 percentile. So you do not need to make the requested resources as the 100%. So to make it simply, we can use the less resources as a guarantee, and on the whole server, we can leave a shared headroom. And this headroom, it should not be the sum of all together, because they will not reach the peak at the same time. So this is the comparison, 90 percentile. And as you can see on the right, on the left side, 90 percentile, and the performance, the resource allocation. But if you allocate 99 percentile, there will not be no problem in performance. But we normalize the resource allocation, and this combines the requested and limit resources, so that we can realize a balanced performance. and there will be less conflicts. So the whole idea or the mentality is that we can utilize better the resources, because we divide it as request and limit. Some of the applications is memory intensive. That's why we also optimize memory. And actually it is even harder than CPU because it is compressible resources. The threshold, but for memory, if it exceeded, then it will be out of memory and it will be killed or crashed. So in the memory utilization, how to schedule it, the memory resource, actually we have a prediction algorithm, but actually it is quite hard to predict it because sometimes it will be some mutable changes. So that means that is why we have the maximum prediction, the memory utilization. So we observe the peak sequence, and that is why we have a simple algorithm to predict the memory and to adjust its resource scheduling. I also communicated with a lot of counterparts or colleagues, and they say that it must be very accurate. Well, actually, at the very beginning, we collect enough data, and then we will make adjustment. However, on its accuracy, this is the memory scheduling for online services. This is our prediction, the next big prediction. And we will divide it into different schedulers. That means at the very beginning, if we do not have enough support for the workloads and our prediction is not accurate, we can just put it into that means the target utilization is different, and this is conservative. For example, when it reaches 80%, this is 85% and 90%. And if it is not that much, and we can put it in the middle part. If it is conservative, and we leave it at the bottom. But if it is very accurate, we can reschedule it to the upper layer. So that is how we do memory scheduling for online services. And in academia, in industry, they all talk about how to improve the efficiency, but why we do not apply that in memory scheduling? That is because first, in memory, if you batch is CPU intensive, when you need the memory, you need to preempt a lot of batches, and it will not be effective. And the second point to make is many online services. At present, it is very hard for us to use batch. So that means this is totally based on online services. And at present, it is quite effective and it has gained good results. This is the simulation, real trace-driven simulation, and it is 80% utilization without OOM. But still, if we improve it, there will be some faults. And we will adjust the proportion of the scheduling, the migration promotion. And at the very beginning, it is of a small scale, and it has been improved from 40% to 61%. So we think this result is quite ideal. This morning, I also mentioned about the host selection optimization, because you want to select the best host to run. In KBS, in Kubernetes, there are several very key metrics. For example, the multi-resource balance and the resource availability. The more resource availability is, the better it will work. And the latest version is it has very simple algorithm for the multi-resource balance, and we introduce a similarity algorithm. The second is resource availability. It has equal weights for CPU and memory, because the workload-aware weights and resource usage dynamics, so that we can adjust it. If it is CPU-intensive workloads, so we can give it a higher priority. We also take affinity into consideration. like the port affinity and the port demand correlation aware. So this is a comparison with the Kubernetes. So in total, we have about 5,000 servers and we have 225,000 pods. And within the community, it is about 25,000 pods. And there will be some failures for schedule the servers, but for hours, performance is much better. We can schedule about 80% of the pods, and also we can schedule 5 to 20% more pods than KBS.
For the third strategy, actually we have the mixed workload. At the beginning, the profiling for the category is quite simple. It's mainly based on the typical business. It's called the high priority long-term service. Usually we just keep them together, we not isolate them together. And we batch them with the low priority long-term services and batch jobs. We have some optimization strategies for that. That was more specifically, but more generally, we want to mix the resources and use the resources together. And this is a single running containers. Well, when the sales event, the volume will increase dramatically and will use more container from the big data. And as you can see, we can have more strategies. And we can add more nodes if it's not so necessary. Actually, we believe this technology is quite mature. And someone asked, can this container be mixed and used? Actually, this should be quite diligent in practice. Because first, the preparation is not that work. It's not that good. For example, if the batch jobs have some mistakes, the whole process may be failed. Well, for the second, if the memory has some questions, then the CPU-intensive workload may only offer limited help. And for the third part, which is quite delicate, I'm not sure how many companies use that. I know that on Tencent Cloud or AliCloud, I'm running this process, but for our Jingdong, we run this process and run these containers in the trusted racks, and we have some data centers in different cities, like in Guangdong, in Suqian. We want to make sure that the data center can be closer to the end users. But for the big data infrastructure, they do not need to be getting close to the end user. So it can be located in quite remote places, like in Xinjiang or Tibet. It doesn't have any influences. So my opinion that mixed workload is a good trend, very promising. But in the practical implementation, we need to take consideration of that according to our business size and the business procedures. But for the last part, I want to take some data as an example for the June 16th anniversary sales in 2019. Actually, we have 29.2 billion transaction volumes on that day, on that single day. So this year, our system do a very proud thing. Previously, on the anniversary sales event, we will buy the machines, buy additional machines to complete the work. Now for this year, we no longer buy any more machines, but also delete about 10,000 machines. So that is efficiency improved significantly, which is very proud. But for the conclusion part, actually, Jingdong is one of the earliest adopter of Kubernetes and container technologies. So we have formed a mature ecosystem for the customization and optimization. And we want to optimization according to your business schedule, and we can have a good performance and reduce your costs significantly. And I believe you can use that according to your own business size. Something I shared, maybe you can adopt it directly, but maybe some others you can take as the reference. Well, of course, I make the presentation on behalf of my whole team. So thanks a lot for the following colleagues of my team, who have made significant contribution to this project. And this is the contact information, and if you want to have more discussion with me, you can contact. And I also listed the contact information of the leader of this project. And if you want or have any problems, you can contact with him. He is responsible for the monitoring of the whole Kubernetes ecosystem. But due to the limited time, I'm not sure. Maybe I can answer one or two questions. Do you have any questions? Thank you. Well, I have a question. When I say that, I thought of the database inspection of DAV for some very average developer will offer some bad circles. I'm not sure, do you need to educate the developer to do the scheduling to have a better performance or effect? But actually, I believe the developer and the business are our clients. We have to probe into their demand and needs. Actually, the developer do not need to worry about I need to have 5 containers or 8 cores or the specific parameter of the workload. But of course, I do not think it's necessary with workload optimization. I just take it as an example. But when we do that several years ago, we encounter such problems. And if the developer can do some contributions, then the subsequent procedures can save a lot of efforts. I agree with that. If the developer can have a more standard writing rules, and then they can save a lot of works, and the whole process will be more efficient. I agree with you. For example, during the scheduling, the developer can define the document when the scheduling stage. Yes, of course, if they can offer some knowledge or contribution, it will help a lot. We will communicate with them more in later. Also, this